On this lesson, we're going to be simplifying radical expressions. If you take a look at this chart, this can help you, but I'm going to kind of teach it in a different way. In the past, I've used the fact that we have perfect squares, perfect cubes, and so on. Some students have a hard time recognizing these, so I'm going to show you how to do this with factoring instead. Now, you may be familiar with the perfect squares more so than the others, but there are specific numbers that we're looking for when we're simplifying radicals. Okay, so on this first one, we're going to look at 27. Now, these are square roots. The first three examples are square roots. So that means I need numbers that are to a power that is either equal to the index or are divisible by the index. So if I factor 27, right, I know that 27 is 3 times 9, and that 9 is 3 times 3. This is kind of like a factor tree, but I'm not going to necessarily put the little lines, to each one of these. But we know 27 is 3 times 3 times 3. So I'm going to write this under the radical as 3 squared times 3. And so now I've got 3 to the second power, which means the root of that is going to be 3. You can also write it this way, right? The square root of 3 squared times the square root of 3. And so the square root of 3 squared is 3. And then under my radical is also a 3. Now, there are some calculators that will do this for you. If you just key in the square root of 27, it will tell you it's 3 radical 3, but that is not helpful because if you just use your calculator, then you're not understanding the concept. How do I simplify this myself? And that's what you're looking for. All right, so on this one, the next one, I'm going to factor 20, which is 4 times 5. So that's 2 times 2 times 5. And then under the radical, I'm going to have 2 squared times the square root of 5. I guess I should put some equal signs here. Now, the square root of 2 squared, right? Remember when my index is 2, I can treat this like I did with variables in a previous lesson. So if I can get this exponent to be divisible by my index, then there's my root. So this root is a 2 times the square root of 5. Now in the past I would have taught this as, right, the square root of 4 times the square root of 5, which is 2 radical 5 because I can take the square root of 4. So it's okay with me if you do that this way, but I'm just showing you kind of a different method, especially when the numbers get less familiar. This can be helpful. All right, so let me kind of cut that off a little bit. All right, so 8 is, let me do this before I put the radical. So 8 is 2 times 4, and then 4 is 2 times 2. So this is what it looks like when I factor 8. So I'm going to keep the 2 on the outside. I'm going to have 2 squared times 2. I'm just going to put this under one radical. So I can take this root out. And when I do that, the square root of 2 squared is 2. So on the outside, I have 2 times 2 times the square root of 2, which is 4 radical 2. And then we are finished with that. Now this next one is a cube root. And so I'm going to factor 54 so that I can find something to the third power or divisible by 3. So this would be, the power is divisible by 3. 54 is 6 times 9. And so 6 is 2 times 3, and 9 is 3 times 3. So you see we have this group of 3. That means I have found my root, right? The root that comes out will be the 3. So then this will be the cube root of 3 cubed times 2. So the part that comes out is going to be the 3, right? Because I have a power that matches my index. Or you could take the power of 3 divided by 3, which is 1. So this will be 3 times the cube root of 2. Now be careful with where you put your index so that you can tell it's your index and it doesn't look like an exponent. It can be confusing sometimes if you write this incorrectly. All right, so that one's simplified. Okay, so the fourth root of 48. Now I know if a perfect fourth power is 16. 16 times 3 is 48. But if I just factor this, right, 48, let's just start with, what did I just say, 3 times 16? Yeah. And then 16 is going to factor as 2 times 2 times 2 times 2, right? Because that's 4 times 4. So 2 times 2 is 4, 2 times 2 is 4, so that takes care of that. So under the radical then, I'm going to have 2 to the fourth power times 3. So now I have grouped all my 2's into a power that matches my index, which means that gives me a root of 2 times the fourth root of 3. Okay, so we're going to do this next one the same way, and we're going to treat the variable on the y the same, right? It needs to be even, which it is, so it gets to stay. And then I will have, let me do this factoring part first. Okay, I'm waiting for that to disappear. So this is 4 times 7, which is 2 times 2 times 7. Okay, so I'm going to have 2 squared times 7 times y to the 8th power. Now the shortcut on this is that I simply divide my exponents by 2 to find my roots. So when I divide the exponent of 2 by 2, I get 2 to the first power. When I divide the exponent of 8 by 2, I get y to the fourth power. And then the 7 I can't bring out, and it stays under the radical. Now I could also write y to the 8th as y to the fourth squared, right? So I have it to the second power, which means the root is y to the fourth. Okay, next. So 32, I keep writing my equal sign, and I'm not wanting it right there, not yet. I just want to factor 32. So I'm going to factor 32 as, let's see, let's just do 4 times 8. And then on my z, I'm going to write that in a different way here in a minute too. So that's 2 times 2, and 8 is 2 times 2 times 2. So now I have 2 to the 5th power, which is not helpful. So I want to write 2 to the 4th power times the other 2 that's there, right? 2 to the 5th power is not going to be helpful. And then I'm going to take the z and write that to the 10th power times z to the 1st power. I'll go ahead and put a first power on this too also. So what I'm doing is I'm splitting that up to reflect an exponent that is divisible by my index and what's left over. If I take 10 plus 1, I get z to the 11th. Remember, that goes back to those rules of exponents. Same thing on the 2's, right? If I add those, that's 2 to the 5th power, and that's what 32 is, 2 to the 5th power. And so when I'm simplifying, right, I can take out these roots, and the 2 and the z then stay underneath. All right, so if I divide the 4 by the 2, right, my index of 2, I get 2 squared, which is 4. And then on the next part, I'm going to have z to the 5th, and my radical will still have 2z. And radicals are simplified when my index or my exponents on what's inside are not more than my index. They can't be equal to the index, and they can't be more than the index. All right, and so if you want to group these in such a way that you're showing the 2, let me erase this and write this out in a different way too. So I could have written this as, right, the square root of 2 squared to the second power. So everything I can write to the second power is what comes out. And then I still have the 2. And then z to the 5th squared, right? Back to those rules of exponents. And then I have the z to the 1st and the 2 to the 1st. So you can see that my root is 2 squared, which is that's where I got the 4. And z to the 5th. And then I have to leave the 2z under that radical. Okay. So whether you're understanding this way or you're looking for perfect squares, you know, either way would be fine. If I was using perfect squares on this, then I would have written it as 16 times 2, but I would still write the z's the same way. All right, so then this would be 4z to the 5th times the square root of 2z. So that's just another way to look at that. All right, so 8 happens to be a perfect cube. So that means I can write it to the third power. 8 is 2 to the third power, and hopefully you learn to recognize some things like that. Now I have to split up the exponent of 8 because that's not divisible by 3. And I want to split it up as the highest exponent I can find that is divisible by 3, and then times what's left over. So this is going to be a to the 6th times a squared. Right? And then I can take the root, right? 2 to the 3rd, the root would be the 2. On the a, I'm going to take 6 divided by 3, so that's a squared. And then the other left over, right? This one stays underneath because I can't simplify it. So 2a squared times the cube root of a squared. I think we have time for one more here. So then the cube root on this one, I'm going to write this as y to the 3rd times y to the 2nd. I can split these exponents any way I need to, and it depends on what my index happens to be. In this case, it's a 3. So I get the root would be, right, y to the 3rd power, that root would be a y. And then I'm left with the cube root of y squared. And then that's it. That's as much as that simplifies. All right, so I'm going to end this video and I'll pick up this lesson on the next video.